started. I'm going to talk about JavaScript, quite a number of things. And we got about 2 hours on our hands. What I would like to do is, I'll probably talk for about 30 minutes, 40 minutes, 45 minutes, whatever. Yield a little bit time for you to work on a little lab. You need a laptop, but if you don't have a laptop, that's fine. We can move around and we can group ourselves with people and work on machines. Even if you have a laptop, I would encourage you to pair up with other people. That's a lot of fun to share. So we'll kind of move around and we'll figure things out as we go through. Think about this for a minute. If this was, let's say, 1996, and somebody came to you and they told you that in the middle of 2015, 2014, the language that everybody would be excited about is JavaScript, you'd have told the person you're crazy, right? Can you believe it that we actually will talk about JavaScript in 2030? And this is, how does it feel to think of JavaScript? I think JavaScript is like this villain in the movie. They kept killing him and keeps coming back, right? That's how it feels. And it's a language that's taken really interesting turns. And who would have thought that this language would actually become a serious language people would be excited about? So it is a language. There are several things that are issues in JavaScript. Inconsistencies. How different browsers handle it, how different environments handle it. It's a language with a very poor name. Think of this for a minute. Would you do this to your kid? Name your kid after a guy who's popular in the neighborhood? How would the kid turn out to be if you did that, right? And yet, that's what happened to JavaScript. They looked around and said, hey, look, this language called Java is getting popular. Let's call it JavaScript. A random name, right? Poor JavaScript has been emotionally deprived ever since, right? And that's a name very poorly. Often very misunderstood. A language that's been misunderstood in so many ways. Now, honestly, how did most of us learn JavaScript? By looking at JavaScript on the web, right? And most JavaScript on the web sucks. So we all learn from bad examples. And years ago, people would read bad examples and learn from bad examples, and they would code from these bad examples. That's changed, by the way. The good news, that's changed. Now people don't do that. Now they just copy and paste it, right? Which is even worse. So we all have learned from bad examples. And as a result, it's hard to come by good JavaScript. But what is really good about JavaScript? Well, it is a very powerful language. It's probably one of the most powerful languages you would come across. Most of us haven't really exploited the power this language offers. Very powerful. It is dynamic. In a way, it is a little bit too dynamic, you could say. It is weakly typed, that's one disadvantage. It is weak typing, garbage in, garbage out. There's no beneficiation per se. But it is a very dynamic language, and we can make use of this dynamic behavior. And very flexible. It supports functional style of programming, and we will take a look at what that is. But it's not a purely functional language. In a lot of ways, people argue JavaScript is dysfunctional if you want to think about it as a language itself. But it's a functional style of programming. It is not functional programming language. What does that really mean? Well, a functional style of programming is where you can create higher order functions. You can, if you're used to programming in Java or C++ or C#, you know you can pass objects to functions. Well, in JavaScript, you can pass functions to functions. You can return functions to functions. You can create functions within functions. So this gives you the functional style of programming. This is available almost in every language today. C# has lambda expressions. C++ 11 has lambda expressions. Java 8 has lambda expressions. So almost every language worth its salt has this facility now. JavaScript has had it from day one. In a purely functional programming language, on the other hand, it will promote immutability. It will promote pure functions. JavaScript doesn't have any of those. In fact, JavaScript is very impure in a lot of ways. So it is functional style, but not functional programming in that regard. We'll talk about how that is a little bit later with some examples. But one of the really cool things about JavaScript is this so underutilized feature called prototypal inheritance. And we will talk about prototypal inheritance. We'll talk about how that works with some examples. I'm not going to flip any slides in front of you, right? Slides are kind of boring. We already stacked you a long set of slides. So we'll just start, we'll write code, we'll play with some examples, and then if you have some questions, we'll go back and change some things, and then work with it. If you're interested in downloading some of these code examples, you can download it from my website. The link is up here, agiledeveloper.com. I'll copy that towards the end also. Don't be in a rush to write it down. It's in the bottom as well. As I go through it, you can see it again. So, let's start with some ground rules. Before even going to the ground rules, how am I going to run my JavaScript? Well, there are a couple of ways to run JavaScript. One is I can create an HTML file, I can write some JavaScript, I can bring it up in the browser. That's the best way to get old and die, right? So that's boring. That's too slow a round-trip process. So I'm not going to do that. But instead, I'm going to just run JavaScript here in Node. So what am I going to do? Well, first of all, what I'm going to do here is, let me quickly show you an example of this. So what is the benefit in here? Well, we're going to run this very quickly. So for example, if you notice, I'm going to go ahead and write a little bit of code. Let's just say, for example, let's say hello JavaScript, right? So I'm going to run this code. How am I going to run this code? Well, if you look at the directory that I have here, all I have in this directory is this file called sample.js. If you look at what sample.js has, it's got that one line of code we just saw. That's all I have, right? So right there is sample.js, and that's the file. I'm going to just run node sample.js. That's all I'm doing. So this runs the code in that file in Node. So what is Node? Node is a little engine that can compile and run JavaScript code. You can just type Node. This gives you what's called a REPL, or read, evaluate, print loop. A REPL is a very nice way to interactively try certain things. For example, I could say numbers equals, let's say a bunch of numbers here, 3 numbers. I can then say numbers dot, and then we could use some functions on it. So for, and I hit the tab key and it fills up what's remaining, and then I could give a function to run with it if I want to. I could also say things like 2 plus 3 and find out what it tells us. So you can play with this node REPL, or you can simply say node and specify the file name to run. But that is too slow also, right? You probably noticed I'm a very impatient guy, right? So what am I going to do to run this? I'm going to just do this, right? So we're going to just write code and run it. And all I'm doing here is I've configured this editor to do whatever I was typing manually on the computer. It is doing it for me, so I don't have to waste my time and effort doing it, and we can quickly see the output. So that's all I'm doing, no magic. So that's all I'm seeing here is the output. So let's talk about some ground rules. The first ground rule is that you really have to be careful about semicolons. Now, JavaScript, semicolons are optional, but optional in a way it'll hurt you when you don't expect it. So always remember to put semicolons. Let's look at an example. So I'm going to say I have a function called foo, and this function takes a parameter. Now, in programming courses, you always have to have a function called foo. That's a requirement. So we're taking care of that requirement right here, right? So foo is the function. And what am I going to do within this function? If n is greater than, let's say, 5, let's say less than 5, what do I want to do here? I'm going to say return, let's say n times 2, else simply return n itself. So let's go ahead and give this a try. I'm going to call foo and send a value of 6. Hey, that's good. Notice it printed 6, right? Very simple. But I'm going to call this one more time. This time I'm going to call foo, and I'm going to send a value of 3. Well, what should it do? Well, 3 is less than 5, so it should multiply 3 with 2 and return the same result. 6, isn't it? Well, not quite. You saw it gave an undefined. Now, what really happened? Well, what JavaScript does is, it does you a favor. It looks at your code and says, oh, poor Venkat forgot to put semicolon here. Let me help it. And it puts a semicolon in place where I least expect it. So it put a semicolon right after that word return, and as a result, it returned nothing or undefined in this case. Well, it doesn't help, unfortunately, put a semicolon here either, because it still put a semicolon here for you, right? So you have to be very careful how you write it. You got to put it right there on the same line, and you can see that it's working fine. So be careful a little bit about some of these rules. Now, the second thing is, how do you declare variables in JavaScript? Well, let's go ahead and say we have a function again here. And within this function, I'm going to say local equals, let's say, a value of 7. I'm going to print the a value for local. So I'm going to go ahead and call the function foo. And you can see it printed the value of local, which is 7. That's what we got here, right? For the 3 people standing, you're most welcome to go grab a chair if you would like to. I hate to see people standing, but if you are happy standing, you're most welcome to stand as well, but you're not required to. So you can grab a chair if you want to. So what do we do here? We just call this instead. I want to print the variable called local, and that's what we did. We printed the variable local. But what if I try to get this variable local over here, right? Well, notice in this case, it gave us an error. It's very unhappy. What happened? It tells us we cannot access local. Why? Not because you called it local, because that variable is in local scope. It's only known within that function, right? That makes sense, doesn't it? Now, on the other hand, I'm going to come back to this code right here. Let's remove this printing of local. And right about here, I'm going to define another variable. Let's say max equals 7. And I'm going to go ahead and print this value of max right there. It printed the value of max as 7. Actually, let's make it 17 just to see the difference. But notice one thing I did here. I did not put the word var in front of max when I defined it. So JavaScript looks at this code and says, hey, Venkat put local, var in front of local, but he forgot to put var in front of max. And it says, what can I do to hurt him the most? And it figures the worst thing it can do is to make a variable global, isn't it? Because nothing could be more evil than global variables. So it says, nice idea. So if I try to come out here and print the value max, notice I'm able to get the variable max outside. So in other words, if you forget to put the word var in front of variables, you make it global, which can be pretty damaging. Why? Because not only you make this variable global, you probably are stepping on another variable that's already defined in another context. Imagine you got several JavaScript files you bring in, and then you're running your code, and you start creating global variables everywhere. And all of a sudden somebody writes another function, and this can go blow up a variable way over there. And if you like debugging, you got a lot of opportunity for that in JavaScript, right? So moral of the story, never define a variable without putting a var in front of it. You always want to make variables local and don't want to make them global, right? Very damaging. You could also use an option script, and the JavaScript run will tell you forgot to define variables, so you could do that to protect yourself. Another thing to keep in mind, if you look at this code right here, notice I printed local right here. That's great. Now I'm going to go ahead and define yet another variable. And this time I'm going to say over here var, let's say max equals 17. Remember how I remember to put the var in front of this. Now I'm going to print the value of max. Everything seems to be fine. But then I come out of this scope right here, and I'm going to go ahead and print the variable value for max. What's going to happen? Well, notice how we have a block of code right here. And we came out of the block of code, and then we are printing the variable max. Well, we know max is local. That we know. But what's going to run if we what's going to happen if we run this code? Well, I run this code and notice it still printed the variable max. I cannot access max over here. That's good, right? It's local. It blows up. However, what about accessing max right here within the function?
Well, that simply worked. So what really happened here? Well, it turns out JavaScript doesn't have this concept called block. So it walks along and comes to line 4 and says, hey, look, nice little curly bracket, right? And then walks away. So it doesn't care about it. So there's no block scope in JavaScript. So you may be misled looking at this from the experience in other languages. There is no such thing. In fact, it's a little bit worse than that. What's happening in this case is that JavaScript has something called hoisting. In this case, the variable max, where is it being defined? This variable max is being defined right all the way at the very top of this function. So there are two things happening. On line number 2, max has been defined, and on line number 5, it is being given a value. So what's the lifetime of max? Lifetime of max is line number 2 all the way to line number 10. But you gave it a value on line number 5, but that's not the birth of this object. That's the naming ceremony of this object. It's been born for a while now, right? It's right up there on line number 2. And so as a result, one convention we follow in JavaScript is we create all the variables in the very top of the functions. When you create all the variables in the top of the function, there's no confusion when you look at this code. Now you may say, wait a minute. I remember people telling me that's the way the old guys programmed back in the days of C programming, right? And along the way, a little after C++, we started doing it differently. In the languages which are more modern, we define variables very close to where we are using them. We don't define them all in the top. Now you're telling us to go back and do the old way. That's correct. Because in JavaScript, everything is defined at the top of the function. Well, but there was a reason why they told us don't define all the variables in the top. Remember, there's a reason why they changed it. Why did they change it? Well, the reason is when you have long functions, if you define all the variables in the top, by the time you get to the middle or the bottom of the function, you don't know what those variables are. It really becomes hard to find out those things. So if you define variables where it's used, it's easy to find out. But there's a very easy way to fix it. Don't write long functions, right? So JavaScript kind of promotes really good practice in a way, so you don't have to worry about that problem. So the moral of the story is define all the variables at the very top. Make sure you put bar in front of variables. That is a much better way. So far so good? Well, how do you define functions? There are 2.5 ways to define functions. Now what are the 2.5 ways to define functions? One is the way that you see people do most of the time, which is something like this. Function foo. And then you probably have seen people write code like this, right? So we could say foo called with, and then let's say a number n. So what is this number n? That's what I'm going to pass right here. So I'm going to say foo with this value of 6 over here, and you can see it print. Anybody who has seen code like this? Almost everybody, right? So I see a few people raising the hand. The other people, what about other people? They're in denial. They don't want to admit they've seen this, right? They've been tortured by code like this. They're like, please don't ask us. I'm not going to raise the hand. Right. Absolutely. We all have seen it. Well, actually, I know the answer. Those who raised have seen it. The others are the ones who wrote it. Right? Absolutely. So yeah, we've seen code like this. Now, what is wrong with this code? My recommendation is don't do this. Now, you're going to say, wait. You are telling me that the best practices that we see on the web are the things we shouldn't do. Because I look at any website, that's how they define functions, why not? Well, this is fundamentally flawed in a certain ways. Now, let's see why this could be a problem. Notice I called foo called with 6, great. Now I say function foo, let's say end over here again. And this time I'm going to say redefined foo called with, and let's say n again. So notice how we are calling this function twice in this case. Is the font big enough, people in the back row still? Is it good? All right. So now I call foo and send a 6 one more time. So what do you think is the output going to be on line number 5 and line number 11. Don't worry about being wrong. Remember I told you it's okay to be wrong. In fact, I am wrong most of the time, or my wife reminds me that, right? So it's okay. It's okay to be wrong. What do you think? All right, let me rephrase. What would you like to see? That you have to have an opinion, right? Nobody can tell you you're wrong about it. What would you like it to be? Foo call with 6, and then redefine foo call with 6, right? That's what you would like to see, but not today. Now notice what happened. It says redefine foo call with 6 both of the times. Now you may say, oh my goodness, that's kind of stupid, isn't it? No. Remember the word euphemism. Well, they call this hoisting. That sounds so much fun, right? What is hoisting? It's messed up. That's what it means. So what really happened here is they define a variable called foo. And the minute they define the variable called foo, how did you define this variable called foo? Well, as a side effect, as an accidental, incidental issue of defining a function. In other words, every time you define a function, you are defining a variable name with it when you give a name to it. So foo was defined right there, and it was bound to this function right here. But JavaScript kind of walks over, it does 2 passes, it comes over here and says, look what I found. I found this variable b, foo, being defined, and simply overwrites the other definition of foo. So once it finishes the passing, the next time it comes around, it says, I'm going to call foo. Well, which one is it? The one it overwrote this time, right? So that's the least, it is confusing when you see this code. So that's why I recommend not using this approach. I said there are 2.5 ways. That's one way, don't do that. A better way to do this would be to say over here, var foo equals function. Now I like this a lot better. The reason I like it is, A, this code is more predictable. When you look at this code, you know what's going on. That's one benefit. The second benefit of this approach is, when you look at this code, you are using a format which is very similar to the format that you would use to define anonymous functions. And for that reason, it is easier to use that consistency. Consistency is a good thing in software, right? Then we don't have to think about certain things. Our brain registers for a few things. It becomes easy to work with things. So we defined a foo right here. Now I say over here, foo equals, and we'll say function. After all, we are redefining this function. And notice this time, the output is exactly what we would like it to be. So what happened here? On line number 1, we defined the variable called foo. And JavaScript says, oh, I have created foo now. And it's a separate variable I created. Remember the word called program with intent. You clearly express your intention here. You didn't accidentally create foo. Instead you said, I've got a variable called foo. Oh, noted. Oh, by the way, I want that foo now to point to this function. All right, there you go. And then you came to line number 7 and you said, I want to change what I pointed to now at this instance. It says, okay, you're allowed to do that. I have the old value and now here's the new value. So when you run the code, it used the old value on line number 5 and gave it a new value on line 7, and then it comes back and lets you exercise that in the last line. So it's very deterministic, very predictable. So this is a better way to write the function. Now I did mention there's 2.5 ways to write the function. What is the other halfway? Well, the other halfway is to give a name of the function right here, name fn. Well, what does that do? This gives a name of a function and assigns it to a variable. This is usually done for people who work in the department of redundancy. So it's better for the rest of us to avoid it, right? So don't use it. It is not very helpful. And some people will tell you that's needed for writing the recursive functions. That's a myth. That's not really true. So there's no really good reason to do that. So I would say avoid that. There's no reason to give a name for a variable. So that is the way that I would prefer to write the functions in JavaScript. So we looked at a way to define functions and using the traditional approach, but also using this better approach, and I mentioned prefer that. Now, let's talk about something else that's really interesting. Max equals function a comma b, and I'm going to say over here, if a is greater than b, return a, otherwise return b. So I'm going to call max over here, and I'm going to send it to this 1 and 2. That's a 2. Hey, that seems to be working. Call this again and say max and 3 and 1. Well, that seems to be working also. Let's try this one more time. So this time I'm going to say max of, let's say 2, 4, and 1. Wait. You are passing 3 parameters, but the original only required 2 parameters. People programming in Java, C++, C#, what will happen at this point? Compiler error, right? Compiler will call you names and will say, how dare you do this, right? And it will curse you and say, you're giving me 1 parameter more than I expected, right? So we take all this abuse from compilers every day, right? I mean, I would say programmers are the most resilient in this world. We get spit on every day by the compilers, and what do? We kind of do that and then start coding again, right? This is awesome. That's what we do for a living. Yes, but what's going to happen here? Well, I run the code. It did not complain. In fact, it ran, and it gave you a 4. Why? Because JavaScript treats you like a guest in its house. It doesn't say, don't put it there. Like, okay, what do I do? It just smiles at you, it's okay. And then quietly cleans it behind you, right? So it didn't complain to you. So JavaScript doesn't complain. It's good that it doesn't complain. That it's bad, you're not sure what it does anymore. Did it really work? Was it really smart to give me the value 4, which is the max? Well, don't have such faith. So it quite didn't work. So it failed, but it failed very quietly, which can be troublesome also, right? Well, what happened in this case really? Well, the problem is this. If this was Java or C++ or C#, and if I ask, or even other languages like Ruby, for example, if I ask you, how many parameters does max take, what's your answer in those languages? It's okay, speak. 2. Of course it's 2. We look at that and say, how do you know? Because you look at the function declaration, right? Your eyes immediately went to line number 1 and said, hey, look at the parameter list. And in the parameter list, I got 2 variables, so that's what my count is. That's correct. But not true in JavaScript. So in JavaScript, let's ask the question, same question. JavaScript, how many parameters does the function max take? And the answer is only as many as you want to give it. So you decide, the power is with you. You decide how many parameters you want to send. So how do I do this? Well, I'm going to call max over here. How many parameters does max take? Well, guess what? It takes 2. It takes 2, right? Right there it takes 2 parameters. Why? Because you said so. Hey, how many parameters does max take over here? Well, max now takes over here 2, 4, and 1. Now it takes 3. So the caller decides the number of parameters in JavaScript, not the function declaration. It is very flexible. Or in other words, in C# or Java or C++, if you want to pass a variable number of parameters to a function, what do you have to do? You got to do something special, right? In the case of C#, you got to say params as a declaration. In the case of C++, you got to mark it var args and write a lot of code around it. In the case of Java, you got to use the ellipses, right? Well, guess what? In JavaScript, every function all the time takes a variable number of parameters. What is special in those languages is normal in this language. Every function all the time takes a variable number of parameters. That is the normal life in JavaScript. So that is why you're able to send this. You say, okay, that begins to make sense, but what about that A and B that is sitting up there? How does that work? Well, here's the way to think about it, right? So we have Shamira here in front of us. I got his name now. And we have Janindu. So there are two people in the front row. Is that right? He's staring at me. He's like, how dare you say that? What about me, right? Oh, am I not visible to you? Well, sure, there are so many wonderful people here on the front desk over here, front row, but I so happen to just note the name of only two people now. That doesn't mean there are only two people, right? I only know the name of two people. Well, exactly the same thing happening here. I just gave two variable names, and those two variable names happen to be a symbolic name for the two parameters in the parameter list. But how many parameters are in the parameter list? Well, I don't know. Go ask the people who called it. So in other words, in the first example that you saw, which is on line number 8, A refers to 1 and B refers to 2. And in the second case, on the other hand, where you have the variables, the second parameter, A is 2 and B is 4, and 1 doesn't have a symbolic name attached to it. Right? That's all it means. Well, then the question is, how do I get to it? Well, in order to see how to get to it, let's remove this code for a second, and let's get back here and say output, and I'm going to say arguments dot length. So I'm just going to print arguments dot length. And notice now it says there are 2 arguments in the first call, and there are 3 arguments in the second call. So this tells us that the number of arguments these functions receive is equal to the number of arguments you actually pass. So in the line number 6 we sent 2, in line number 7 it sent 3. What's that undefined? Well, our function doesn't return anything useful, so that's undefined because we're printing what's not being defined when we print it out. So far so good? Well, then what are we going to do here? Well, var large equal to, let's say for a minute, arguments, let's say 0, and then I'm going to say return large. That's what I'm going to return from here, right? So notice I'm returning the first values now. But I really want to find the maximum, so what should I do? For I equal to 0, I less than arguments dot length, I plus plus, and then I'm going to say over here, what's the next step? If large is less than arguments of I, then large is equal to arguments of I. So now we are finding the maximum value in the entire result that's been given to us, values given to us. So notice how in this case it printed 2 and 4. Now if you were to modify the second occurrence to a 3 parameter, remember the 8 that I was trying to send, it is able to give us the right result, which is 8. So what did we do? We're using arguments. Well, notice in the function, I no longer use A and B, right? I'm not using A and B at all. So in a sense, you could go up here and simply get rid of A and B because you no longer are using it. It doesn't matter because we have no use for it. So in other words, every function in JavaScript always receives a variable number of parameters. By looking at the function, you cannot say, you got to know a little bit more, right? So when a function doesn't take anything, how many does it take? It takes any number, right? It doesn't mean it doesn't take any parameters. That's what makes it a little more complex as well. Now, I made a mistake in this code. Does anybody know what I did wrong? There's one error related to what we talked about so far. That's correct. On line number 3, he's been awake. He's been listening. Absolutely. Variable declaration on line number 3. Notice I said for I equal to 0. Now, here's the fun part. If you had another function somewhere in the code, and if it used a poor variable called I, you just stepped on its toes. Whoops. Be very careful, right? So the right way to do this code would be to say var foo, I equal to 0, and that's the right way to declare it. Be very careful defining things. So we talked about arguments. So what is arguments? Arguments is a special variable in every function in JavaScript. That arguments special variable, if you want to call it a keyword, you can call it a keyword. But that variable arguments refers to the parameter list being given to this function, and you can navigate through it. Now in this code, as you can see, it is able to handle variable number of parameters, right? So if I say max over here with 3, 4, 5, let's say 1 and 2, notice it's able to handle it. Comma, let's say 9 or 8, it's able to handle it. But what if I call this with nothing? What's going to be the output? The arguments list is there, but it's empty. So what will happen if you get the first element from an empty list? Well, in Java, you get an index out of bounds exception. But remember how JavaScript treats you like a guest in its house. So it's not going to tell you that. Instead, what is it going to give you? Undefined, right? It's going to give you undefined. So when you run this code, notice how it gives you undefined. If you want to handle that though, you could. So what could you do? You could go up here and say if arguments.length is less than 1, what do you want to do? Throw. Hey, notice that word throw. Only in exception handling, the JavaScript is like Java. Everywhere else is different, right? So you can throw exceptions. And what can you throw? Well, in Java, what can you throw? Only an object of exception, right? That's all you can throw. What can you throw in JavaScript? You can throw an object. You can throw a number. You can throw a string. You can throw anything you find. It's okay. That's okay. Somebody was angry there. You can throw anything you want to throw. It's like being in a bad marriage, right? It doesn't care. You just throw things because you're angry. You can do that in JavaScript. No restrictions what you can throw. So in this case, I'm going to throw, you gave nothing, we will come burn your village, right? Whatever message you want to throw, absolutely. So when you run this, of course, what's going to happen? Well, arguments.length, see I said large, it's just undefined. So large, garbage in, garbage out. So length, right? Sorry, length. So there we go. And it gave an exception, and you can deal with the exception. How do you deal with the exception? Well, you could put a try block, and then you could put the code inside the try block, just like you would do in Java, right? And then you could say catch an exception. You could print out the exception if you're interested. You can see that exception came out. You could even put a finally block, just like in Java and C#. And then within the finally block, you could say, after code, whatever you want to call it. So you can see after code is being called, right? And finally will be called even if there's no exception. So if I go back here and say 1, 2, you can see that after code is run. So that is an example of how you can check the arguments and you can deal with it. So we saw the arguments, that's great. But then there's one other interesting piece, which is called the this. So we saw arguments is a special variable name, one more variable called this. Now what in the world is this? Think of this as a context object for a function to run. So if I were to define a function here called greet equals function, and I take a name as a parameter, and within this I'm going to say over here, let's say hello plus name, right? So I could call this function. So I could say greet, and we could say Chaminda here, right? So we could greet Chaminda. Now in this case, of course, I'm calling the greet function, and on line number 1, what did I do? This is going to be a bar, JavaScript syntax. So it says hello Chaminda, great. But in this case, of course, we use the word hello from here. Where did that come from? That's a literal way passing. And where is this name coming from? That's a parameter we are getting from this case. But rather than doing this, we could do a little different. We could come back to this code and say this dot to uppercase. So I'm going to say plus a little space and that. Well, that fails. Why? Because it says, I don't know what you're talking about. What is this to uppercase function? Well, I'm going to say in here greet, but I'm not going to call the function like this at this point. Instead, I'm going to say greet.call. Now, all of a sudden, I am calling a function called call on the function itself. This is a bit weird. We thought we were calling functions at this point. Now we are calling a function on a function, right? Meaning we are treating the function like it's an object. Well, that's because functions are objects in JavaScript. And objects are functions in a way. So we'll see how that is in a little later. So this is calling a call function. Then I'm going to say hello and then comma. And what am I going to pass over here? The name I'm interested in calling at this point. So we can see how it printed hello Chaminda. But notice it's an uppercase. How did it become uppercase? Well, we sent a lowercase hello, but when you call the function called call, the first argument becomes the context object. So in other words, when you do a call, the first parameter binds to the this variable on the function, and the remaining parameters become the parameters of the function. And in other words, we are binding the context object when we make this call in this function. Now, let's say for a minute we are interested in passing multiple names to this function. So we're going to say name1 comma name2, and right about here we could say plus, and then we could say name1 plus, let's say name2. So notice in this case we are providing two names. So now we could say over here, we could say call. Let's just say in this case, we even put a little and here because we're passing two names. So we could say, for example, over here, Jack, comma, let's say Jill, and we could say hello Jack and Jill. So we can see how easy it is to call this function and pass multiple parameters. So if the function is supposed to get n parameters, you would pass n plus one parameter, where the first parameter is the context object and the remaining parameters are the real parameters. Of course, if you don't use this, the first parameter will get ignored and the remaining parameters are the parameters that get used automatically. So this gives a context object. Now, why would you use something like this? Well, later on when we start building classes, we can see how we can benefit from this in terms of the context object. But there is one small problem on our hand. The problem is you probably have something like names equals, and you have Jack and you may have Jill on your hand. Where are these going to come from? Well, the chances are these are coming from your query string, for example, in a web application, right? So what do you normally get? You get a collection on your hand already. And how silly it is to get a collection only to tear it apart and get one element at a time. That's boring to code. That's redundant code, isn't it? So if I want to use a call method right now, I would have to write a silly code like this. I would have to say something along the lines of something like greet dot call, and then I would say hello, and then I would say, you know, names square bracket 0 comma names square bracket 1, and we could write code like this, right? But that's kind of silly. We got to write that code to tear apart a collection that already we have. But rather than doing that, fortunately what we could do is we could simply say greet.apply. And apply method takes first this parameter, and the second one is a collection itself. We don't have to waste our time and effort tearing apart the collection. So what's the difference? A call takes n parameters, whereas apply takes a collection of parameters as the second argument. Right? So we can simply take a collection and pass it down using the apply method, and that becomes a lot easier to work with. Now, you can go a step further with this. You could also use a command called bind. And bind will bind a particular object to your context object. If you're using things like jQuery, they do this a lot under the hood. In fact, most of the libraries like jQuery is written so we don't have to do all of this. right? This is all hiding the details so we don't have to be messing with these things. But the problem is this. I come across a lot of programmers who use jQuery and they tell me, I know what this does, but I don't know why it does this, right? And I ask them, why doesn't this code work when you want it to work? And they say, I don't know, I got this from the web. And have you looked under the layer and see what jQuery does? And they say, no, I cannot understand anything if I look under that. And that's a disaster, right? That's dangerous. One of the rules of programming is we should always know one level below the level of abstraction we work in. As a programmer in JavaScript, you cannot use JavaScript saying, but I don't know what JavaScript is, but I'm going to program in it, right? This is like you invite a plumber into the house and he walks in with a little, a wrench and he says, I know somebody gave this to me, I'm still trying to figure out how this works. You're not going to be comfortable leaving this guy at work, right? So we should know our tools. Languages are tools we use. So we have to dig in and say, and this is where curiosity comes in, right? And when you look at something and you say, how does that work? And the next thing to do is dig in a little bit and say, I want to know how that works. And so this is the beauty today, right? When I was a child as in a young programmer, this is funny to have children at home. Because the other day, my little boy, I was taking him to the store, and he asked, what's a typewriter? And I got excited, and I said, oh, you know what a typewriter is? Daddy wrote his thesis on a typewriter. It's a machine. You insert a paper, you type on it. And then he listens very patiently. And when I'm finished with all this excitement, he said, and why would you do that? Why would you use a printer? And I kind of realized, oh boy, he doesn't have a clue what a typewriter is. And I left him at the store, ran home so I could hide all my floppy disks. Imagine what would happen if he finds those out, right? And that is kind of the life we live in. Things change so rapidly, right? We don't see what's there. Well, today, I was at a friend's house, and he's got a beautiful 4-year-old daughter. And she was, having fun, playing stuff, and then suddenly she said something very authentic. And her mom said, sweetie, are you sure about it? And in a very straight face, she said, I'm very sure, Mommy, because I Googled for it. I just melted hearing that, right? And this is a 4-year-old kid. Of course it's got to be good because I Googled for it. Well, back when I was a child, I had to go to the library. Uphill both ways, right? And to request for interlibrary loan, you had to wait for books to arrive a few weeks later. Today, everything is in our fingertips, right? We don't even have to go anywhere. We could have these laptops, we could be having our mobile devices, we could look for it. We got information overflow in front of us. So, this is the funny part of the world. This is where the God has created answers around us. And they want us to only have the questions. Isn't that weird? We don't have to have answers anymore. All you want is the questions. If you have the question, there's answers around you. So the question is, what question do you have, right? And that is what the curiosity really is about. What do you have as a question? Because answer is abundant around you. The only thing that is missing is the question you have. So it's a beautiful world where you get to pick the question and the answer is provided already. That's like playing the game of Jeopardy all over, right? So that is the beauty we live in. So when you look at something like this, you say, hey, I got a question here. How does this work? And then you got answers, of course, right? But asking that question is the most important. That's the fun part. So we see how that works, and the apply method really says, I'm going to send a collection of parameters to you and use it. So we just looked at the apply method and we used it. Let's go to a higher order function. What is a higher order function? A higher order function is where a function can take other functions as parameters. Let's look at a couple of different examples of this. So let's say for a minute, I got numbers on my hand, equals, let's say 1, 2, 3, a bunch of numbers, and I want to print these values. How would I print it? For int I equal to 0, I less than, let's say over here, numbers dot length, I plus plus, var, right, not int, var. And then what should I do here? Print out numbers dot, well actually square bracket I to get the value out of it. That was a lot of effort, isn't it? You got to create a variable I properly, set it up properly, and then set the boundary condition properly, increment the value properly. That is a lot of work. We don't have to do all of that. Instead, we could use a higher order function. So we could simply say numbers dot for each. So what am I doing within the for each function? Well, the for each function, where's that coming from? Well, I'm going to go to node, var numbers, right? Numbers equals 1, 2, 3. And I can simply say numbers dot for each. So you can see the function. I was just checking to make sure I got the right syntax here. That's an uppercase E. So now that I have this, what do? This expects a function as a parameter. Normally we pass an object to function. Here we are passing a function itself. And what does this function do? This function says, given a number, we'll call it value, I'm going to just print out the value that you give me. So this is a higher order function. So for each is a function. We call the for each function on numbers, but what did we do? We passed it a function itself. And we said, hey, you do the iteration, you do the looping. I'm not going to waste my time doing this. Right? This is like you get into a taxi and say, take me to this place. And then you spend your time reading a book or staring out the window and enjoying nature, what have you, right? And you're not worried about the details of which direction to go, what street to take. I don't have, any capability to drive around in most places. But I can spend my time giving an instruction. Take me to this place, please. And assuming you have a good driver who's going to do that, you can spend your time just focusing on what you're going to do when you get there. And so you said, my job is to say what to do when you get there. And what is that? Print that value, each of those values when you iterate. So you put the iteration on autopilot. And then you said, go loop through, and as you go through each of the elements, simply print the values for each of those, and that's all I'm going to do. That's all we did, right? So this is a higher order function. It is a function of style. What are we doing here? It is declarative. What is declarative? In an imperative style of programming, there are two smells in imperative style. One smell of imperative style is mutability. You mutate a variable over and over and over. Look at line number 3. You constantly modified the variable I. That's mutability. Other smell of imperative programming is you not only tell what to do, but you tell how to do it. In driving, we call them backseat drivers. You know those people, right? They sit next to you and they tell you go somewhere and they keep telling you, oh, don't go this lane. Go left, go right. Don't go fast, don't go slow. What do you do with backseat drivers? No violence, no, right? So that's like backseat driver, right? You're controlling the iteration every step of the way. You're saying, iterate, be quiet after you said iterate. You said, no, get the value I to 0, increment it now, check if the value is this. Like, that's noise. In the bottom one, it is declarative. Hey, take me over there, please. I'm done. I'm going to read a book or do something else more productive. And I have the trust in the driver, and the driver takes me where I need to go. And if the reason they cannot, I expect the driver to interrupt and ask, excuse me, there's a problem here, can we go, this other route, whatever, right? That's their problem. So you put it on autopilot, and you said, go, do this for me. It's declarative. You say what you want to do, you're not focusing on how to do it. Well, who decides how to do it? The underlying library does. The for each is your driver. You say, hey, for each, you take the responsibility. And I'll tell you what to do on each element, which is line number 8, right? That's what you're doing here. So that is the functional style here. Now you can do more with this. For example, let's say I want only to print values which are greater than 3. What can I do? Well, remember I mentioned to you that I don't want mutability. I don't want to mutate stuff. I don't want to be doing low-level stuff. So I want to print only values greater than 3. Well, one way to do that would be to go back to this code and say if value is greater than 3, then print it. Did it work? Yes, it did. But notice how we came back to low-level details one more time. Instead, we could do this a little differently one more time. So rather than doing this, what can we do? Comment that out and go back here and say numbers dot. But this time, let's get back here, and I'm going to say dot, and notice there's another function called filter. All I'm doing is I'm hitting a tab, and it's telling me what's available, right? So if you don't put anything at all, you just put numbers dot, and you hit the tab, it lists everything available for you. So you can kind of take a look at what all is available, and you can poke around. And so this time, what am I doing? I'm simply saying here, I want you to filter. Hey, what is filter? Filter is going to cherry pick only things you are interested in asking for and discard everything else. So in this case, filter, and what does that do? Function, and this is going to take a value, and what am I going to do here? Return value is greater than 3. So what did I do just now? And then I say dot, and then I say for each, and then function value, and I'm going to simply say over here return, or rather print out the value itself that I'm interested in printing. Now what did we just do in this case? What we did was we first applied a filter operation. And we said, given this collection of things, the function you sent to filter returns a Boolean true or false. If it gave a true, it keeps the value. If it gave a false, it discards it. So in this case, we return a value greater than 3. Apologies for the color here, that's greater than right there. So what does it do? It says, I'm going to keep values greater than 3 and simply ignore other values. So we saw how that could be done. Okay, but what if I want to total all these values and not just print them? We are just sitting there, looping through one value at a time, getting a value and adding it. That's a lot of low-level stuff to code. Well, we don't have to do that. Notice the result was 21. Instead, we will simply say over here, output, and what am I going to output at this point? Numbers dot reduce function, given an A and B, return A plus B as the result from here. So notice we got the same result now. But we used a function called reduce. And what does the reduce function do? The reduce function takes the collection, applies the function we provided on the A and B being the first two values. So A is 1 and B is 2. What's the result? It's a 3, isn't it? Calls again. This time A is 3, the result of the previous call, and B is the next element. 3 plus 3 is 6. Calls again, A is 6, and B is the next element 4. 6 plus 4 is 10. So it groups these pairs of values where the A is the result from the previous call and B is the next element. So it keeps tallying these. It's accumulating the values. But reduce doesn't have a clue what it's doing. Reduce simply says, I'll work with these combination of values. You could use reduce to total. You could use reduce to find a product. You could use reduce to find the maximum value, the minimum value, whatever you want to do, depending on how you control that function, right? You decide what that function really means to you. So that is an example of writing a functional style of code. And so when you start programming, look for these kinds of functions. You start writing code very differently now, using more of an elegant functional style rather than the imperative style. There's a performance consequence. The functional style in Java may be a little slower than the imperative style. But don't throw away good code in the name of perceived performance. First ask not how fast it runs. Ask if it runs adequately to the speed you want. There's no point in asking for a Ferrari and drive on the streets of Colombo when you have traffic, right? Use this. Sometimes the bicycle is the fastest to get around, or run if you want to, right? So we have to ask, how fast can it go? Sometimes you can go really fast, not by getting the fastest machine, but being more efficient, right? So we have to apply some of those contexts. People use this misguided notion, I got something very fast. Well, no, something very fast will actually make me very slow. Sometimes we have to find what is going to get me there faster, not how fast it is. in absolute measures, right? That's where things get tricky in what we try to do. So evaluate performance and see if it's adequate for your needs. That's what is important. The last thing I want to talk about before we get to an exercise is this. Let's talk about one thing before we go further. If A is equal to B and B is equal to C, then A is equal to C. Would you agree with that? Absolutely, right? If A is equal to B and B is equal to C, then better be that A is equal to C. You'd be very upset if it's not, right? Absolutely. Well, let's try this. Hey JavaScript, tell me if 1 is equal to 1. Say sure. Why not? Thank you. So tell me if 1 is equal to 1.0. Right? So let's reverse this a little bit. So let's put this as a 1 and let's put this as a 1 here. And tell me if 1 is equal to 1.0. It says, sure. Why not? Well, we just agreed that 1 is equal to 1.0. No. So what's happening here? The two equals in JavaScript is also known as bad idea. Most JavaScript on the web will use two equals. And we should avoid two equals as much as we can. Why? Because two equals performs casting and conversions while performing the check. A better way to do this is to use three equals. Now you can tell your colleagues you're really cool because you use three equals and not two, right? So what does three equals mean? So notice I made all of these three equals and consistently all of them are false. Why? Because of course a string 1.0 is not equal to a number 1.0. Of course a number 1.0 is not equal to a string 1.0. And of course a string 1 is not equal to string 1.0. So that's being consistent. So for most part use three equals and not two equal. Similarly for not equals to, don't use exclamation equal, instead use exclamation equal equal. And that says it's really not equal to. And keep that in mind when you perform comparison, use three equals or, like I said, use exclamation equal equal, use that notation rather than using the equal, not exclamation equal itself. So, that is where I'm going to stop for a little break. What I would like for you to do is to try this example, and I'm going to make this font a little bit bigger so it's easier for you to see. What I would like for you to do is, I know we have fewer computers here than the number of people. However, invite somebody to pair up with you, or 2 or 3 people join together, move around as you need to. And if you don't have a computer still, be bold and write on a piece of paper. And then write the code. You wouldn't have a program running on the computer. But once we are done, we can compare notes. So how about exactly 10 minutes for you to work on it? And I'll start back at 10 minutes from now. So give that a try. Simply say, for example, prices dot, we could use a filter And the filter function is going to take price, and it's going to say return price is greater than, what did it say, 25, right? So that's going to return a price greater than 25. And then we could call dot reduce on this. And then this could take a function price 1 and price 2, for example. And then we could simply say return price 1 plus price 2 to perform the total of the prices. And then we could print the result. Whatever the result should be, we could print it, right? So we could do that. Now, just any questions before we move on? I want to talk a little bit more about this. But questions, comments, anything? Okay, so look at how expressive this is, right, compared to sitting there and doing loops and all that. But a couple of things. As nice as this is, one place where I get a little anxious, especially in JavaScript, is the syntax for declaring a function still is a bit verbose. And if you're taking a function that takes multiple parameters as functions, it can get very difficult to read the function. So what I would recommend to avoid that problem is, don't ever fear to write readable code. Sometimes people feel they have to make the code, complex and hard to understand. That's not a good pride to have. Don't ever feel bad to write readable code. So if it really makes it easier to read, what is it you're filtering? You could say greater, right? Greater. So you could say than, let's say 3, or 25 rather, right? So we could say, for example, right here, we could say greater than 25 equals function, takes a price, and return price is greater than 25. So we could break it into these smaller functions. There's nothing wrong with it. And then we can say over here, what is this function really? Well, all that this is doing for me is add 2. And so we could say add 2 equals function. And then we could just put that function right here, which is the add 2 function. And the only disadvantage of this is people will actually understand your code, right? And so if your intention is to confuse people, don't write like that. But if your intention is for people to actually understand the code, don't hesitate to break it into smaller pieces. And then that becomes easier to say, oh, so you're filtering things that are greater than 25 and reduce add 2. So one of the things to keep in mind is the energy it takes to understand a code should be very minimum. Why? Because if you're spending a lot of energy to understand code, then you're not going to be able to maintain a lot of code. But if the energy to understand a code is less, you're able to maintain a code a lot better. So write readable code rather than writing code that's hard to read eventually. That's a choice we have to make. It takes a bit of effort to do that, but we can certainly get to that point. So that is an example of how we can write that function. Great. Now, how do we create these objects? Well, functions are objects, and objects are simply a collection of properties. Let's first create an object, can we? So var person equals. In JavaScript, you can create an object just like that. You don't have to worry about wasting a lot of time and effort creating classes if you don't want to. So in this case, I'm going to say first, and let's say the first name of this person is John. So we could create very easily. We could say last, and let's say this is Smith. And we just created a person object. So we could say person, and we created a person object. Well, this is called the JSON notation, or so-called Java object. This is called JavaScript object notation. And JavaScript object notation gives a very easy way to create objects. So we can put properties in objects very easily. Now, not only can we put properties in objects, we could also have functions. For example, play. And we could say in here, we can have a function, and we could say something like playing, for example, right? Playing. So we could simply say person.play and call the play function on the object itself. So we could do this very easily, as you can see. So this is the way for you to create objects in JavaScript very lightweight notation called the JSON notation, or also the JavaScript object notation or JSON notation. Very easy, very simple to create it. Well, that's great, but we can create classes also in JavaScript. How do we create a class? Car equals function. So there we go, we created a class. You say, wait. You created a function, not a class. No, seriously, we created a class. If you're not really sure, notice I used the uppercase C. Well, you're laughing. That is a convention in JavaScript. In convention in JavaScript is you create classes the same way you create functions. So there is no difference in how you create it. There is a difference in how you use it and what your intention is. So in other words, you could do something along these lines. For example, let's say for a minute here, you could say in here, let's say creating. So creating. I could say car like this. Hey, look, we just called it like a function. Yes, and don't do that. And the reason is, our purpose on line 1 was to create a class and not create a function. So what does it really mean creating a class? Well, in JavaScript, you don't really create a class. You actually create a constructor. So think of a constructor as an object factory. If you think about it this way, it becomes clear all of a sudden. You create a constructor which is an object factory, and that can be used to create an object for you. Now, a couple of things to keep in mind before we go further. If I say type of, let's say 1, well, that's a number, sure. What's the type of hello? That's a string, of course. What's the type of car? That's a function, of course, right? So we saw a number type, a string type, and a function type. But instead, we're going to say var car equals new car. Now I say type of car, and notice that's an object. This is a lowercase car that I created from a new car as a constructor. Did you notice when I ran this, it called creating as well. So what is it doing? It is constructing an object in memory. What does it really mean, constructing an object in memory? Well, let's go a step further with this. I'm going to specify the year of this car, 2013. So I'm going to pass a year in here. So, but how do I get the year? I'm going to say car.year. It says undefined. Where did the year go? Well, we didn't set it. So I have to come back in here, and I got to set the year of the car. Now think about this for a minute. I have a function, but this function is used to create an object. And once I create an object, that object's year has to be set. In other words, there's a context that you're dealing with. So the way you can specify the year has to be set into this variable is to set this into the context. So you say this dot year equals year, and now notice you get the year value. So we have to understand what this word's new car really means. In order to understand this, I'm going to dissect this into 3 steps that are going to happen. Well, what are the 3 steps that are going to happen? Well, the first step is 1, create memory for the object. That's the first step, right? It creates a memory for this object. Well, okay, what's the next thing it does? The next thing it does is runs the constructor in the context of the object. We'll call it the inst. So we'll say the inst is the object. So we'll come back to this in a second. So it runs the constructor in the context of the object called the inst. I want your help here. The name of the constructor is car. So if you were to write this as a function call, this is going to be inst equals allocate memory, right? So inst equals allocate memory, done. And I want you to tell me, what's the next step? How is it going to call the car function? Come on, you can do it. Read line number 9. Runs the constructor in the context of the instance. So what do you think is going to happen on line number 11? Don't worry about being wrong. Car dot, that's correct. Car dot call. So car dot call, inst comma year. Make sense? So now you know how this works. Because within the constructor, notice line number 5, or rather line number 3. What did we do in line number 3? We said this dot year equals year. Well, what is that word this? Remember, that's a context object. Where does that come from? From the first parameter of the call, isn't it? So now you know what the magic is. So it's really creating a memory, running the constructor with a dot call with that as a context object. So far so good? And the next thing it does is sets the instances prototype to the car's prototype. That's the last one. I don't know what that means. We'll come back to it. It sets the instances prototype to car's prototype. Okay, that's good so far. What does it really mean? Well, the way it means is this. Think about it this way. Every JavaScript object has a prototype. So what in the world is a prototype? Think of a prototype like this guy here. It's a bag I carry around almost everywhere I go. It's always with me or very near me. Well, that's my prototype. It's really a bag with a bunch of junk I carry around the world, right? That's what it contains. Now, what is the benefit? The benefit is you could come to me and say, hey, can I have a change for a few rupees? And guess what? I do have a change for a few rupees. I can give it to you. Why? Because I know I need this. I have it in my wallet. But if you say, hey, can I have a change for a few euros? Well, there's really no reason for me to carry euros in my pocket. But I won't say no to you. I will immediately reach into my prototype and I will get you change for my prototype because I do have some change for euros and various other currencies I carry depending on when I need it. So in other words, think of a prototype as an object you can reach into. It's a bag of stuff and every object has a prototype. And guess what prototypes have? A prototype. And guess what those prototypes have? A prototype. Until the very last prototype doesn't have a prototype, right? So there's a chain of prototypes and the very last one, a central prototype, doesn't have a prototype. So let's understand how this works with an example here. So person equals, let's say over here, first. And I'm going to say John over here. That's enough for now. Now I say print out person, and what does it say? First. But then I say dot proto. You see that? Look at what John has. John has a prototype. And what does this prototype have? Nothing. This is like a guy I ran into. I said, what do you do? And he said, very nobly, he said, I help my dad in the village. At the village. I said, that's noble. What does your dad do? Nothing. Right? So that's example, right? This is like awesome. It's got a prototype. What does he do? Nothing. But I want to say, hey, prototype, I'm curious, who is your prototype? Huh? What does he say? No. That's the very last guy, right? He doesn't have any prototype after that. But every object has a prototype, right? That's great, isn't it? So far so good? So we got a prototype. Now notice what I'm going to do. I'm going to go back and say, remember what I said? If I don't have anything, something, what do? I go to my prototype, isn't it? This is called prototypal inheritance. Much better than the regular inheritance. So notice this. I'm going to say person dot first name. And I'm going to ask the person's first name, right? I'm asking for the property called first name. Sure, no problem, because the person has first. But on the other hand, I say, hey, person dot work. What's it going to do? Fail, right? Because a person has no work method, it blows up. Sorry, couldn't do it. But instead, I'm going to say, a person dot proto equals, and I attach a new object now with the work method which has a function called working, right? So now, notice when I run this code, it says working. Just observe what happened here. Person has no work. We went to the person, attached a prototype to the person, and said, hey, you person, you are going to point to a prototype. What is a prototype? It's a JSON object which only contains a work method, right? And now we went to person and said work. What does it do? It went to the person all the way on the top and said, hey person, I want to call you a work. And the person says, work? I don't have that with me. I don't have that function. But hang on a second. Let me check with my prototype. And guess what? The prototype says, yeah, I do have a work method. Great. I'm going to send it to you. So notice how it automatically does a dispatching. Much like inheritance in Java and C# and C++, with one difference though. Inheritance in Java, C# and C++ are static. The minute you inherit, you cannot change it. The base class is fixed. Whereas here, notice what I'm going to do. I come back to the person, the same exact person dot proto equals, what am I doing? I am changing the prototype of the person, not the person, but the prototype of the person, right? And I said function, and what does this do? Have fun working, not just work. So now I say person.work, and all of a sudden it's a different implementation. And how much change we made to the person? We didn't touch the person. We only changed the person's prototype, right? In fact, we could have gone a level below. We could have gone to the person's prototype and set a prototype of the person, 2 levels below, and the person wouldn't even know this. What does the person say? I don't know what work is, I'm going to send to this guy. And he says, I'm going to send it to that guy. So it can be dispatching. So you can modify, it feels like you're modifying your inheritance. This is what is prototypal inheritance. And this is a very powerful concept in JavaScript, right? Gives you a really good amount of power on your hand. Well, that's great, but how do we make use of any of these? Well, let's look at an example here. Car equals function. Okay, remember one thing. When an object is created, I said 3 steps. Remember the 3 steps. Memory is allocated. The constructor is called with the object as a context. And the prototype of the object is set to the prototype of the class, of the function, right? The prototype of the car is going to be set to the function car's prototype. Remember one thing, once this is done, what is the relationship between the object and the function after the object is created? There's no relationship. It floats away, right? They're not connected anymore. So keep that in mind. So notice now, I'm going to say over here, this dot year equals year. So we set the year value. So I say car equals new car 2013, great. Then I say print over here car dot year. So that's printing it. But then I'm going to say over here, see if this makes sense, car dot drive equals function distance, and I'm going to say driving. Watch this for a second. Now I say car dot drive 10. It fails. It says, I don't know what you're talking about. I don't know what a drive function is. What's wrong? Where did I put the drive function? On the car function. What does the car object say? I don't know what drive is. How is it that it doesn't know what a drive is in that case? Why? What's wrong? It's not on the prototype. It's not on the instance. You go to the car and say, do you know what drive is? No, but let me check with my prototype. What's the prototype of the car? It's a prototype of the car function. There's no connection between the car function once the instance is created. So notice what I'm going to do now. I'm not changing anything else in the code. I'm just going to go up here and say dot prototype dot drive. I added the function to the car's prototype. And he says, oh, cool, I can do that. Why? Because the car instance's prototype is the prototype of the car function. right? That's what it's connected to. So whatever is in the prototype, he's able to get to it. So far, so good. Now here comes a small problem. Let's say for a minute that I'm going to go ahead and add a drive method in the car's prototype. And what am I going to do here? I'm going to say this dot miles plus equals to the distance. I'm adding it to the distance in here, right? Okay, that's great so far. I'm going to set the miles property. But where is the miles property coming from? Well, if the miles doesn't exist, I have to set what the miles is. We could say car.prototype.miles equal to 0. So now let's go ahead and say print out car.miles. Hey, great, isn't it? So far, so good. So what did we do so far? Seems like it's working. Car's prototype has a miles. Car doesn't have miles yet. And prototype.drive, drive is coming from the prototype. So you went to the car and called drive. It called the drive on the prototype. You called the car's miles. It gave you the miles. So far, so good, right? But wait a minute. I create one object of car. It's a memory. And what does its prototype point to? The car's prototype, right? I create another object of car. What is its prototype pointing to? Same. Both of them are pointing to the same object, right? Stay with that for a minute. Now think about that for a second. Now both the cars are pointing to the same prototype. Where's the drive function? On the prototype. How would you feel if you drive one car and the other car goes with it? Not so happy, right? You say that's voodoo. Why is he following me everywhere I go? He says stop. Why? Because if you move, I move. Seems really odd, isn't it? Something is wrong here, isn't it? Well, let's ask for your help. What's your name? Spell it for me. I can see that. Shatan. Excellent. So, can you help me? He said yes. So he's in trouble now. So, let's say for a minute, you're going to be my prototype. Can you? He thinks so. All right. That's a good reason. Here's my prototype. So, what's your name, sir? Sudisha. He wants, let's say, a change. He says, can I borrow, 10 rupees from you? Seems like a nice guy, is he? Yeah, seems like. So I'm going to give him 10 rupees. So that's so fast. Okay, so he's happy with it, right? So he's got it. He's happy with it. Seems like a nice guy. About 2 hours goes by. He sees me and says, Venkat, thanks for your timely help. Here's your 10 rupees back. Now we have built a trust between each other, right? Absolutely. So he's trustworthy. So tomorrow he sees me and says, hey Venkat, can I borrow 1,000 rupees from you, please? Well, we built a trust, right? So it's only logical that I give him 1,000 rupees, right? Absolutely. Except for one problem. I don't, he's like really anticipating this, right? I don't have 1,000 with me. What should I do? Go to the prototype. Could I have it, please? He gives it to me. So far, so good. And I give it to him. About a few hours goes by, and he says, here's your money back. What should I do with this 1,000? Come on, be great. Keep it. Absolutely. Anybody has a problem with it? Right? Not him. Does it make sense? What did I just do? I took the money from him and gave it to him, but when I get it back, what am I doing? Keeping it. If you understand that, you understood how JavaScript works. Gets are deep, sets are shallow. Let me repeat that. Gets are deep, sets are shallow. When I don't have something and you want to get it, I'll go deeper. I'll go to my prototype and say, excuse me, can I have it? I don't have it. My prototype says, if he has it, gives it to me. Otherwise, what does he do? He goes to his prototype. Gets are deeper, but sets are shallow. When you try to set something, the first object receives it. Now let's get back to the example. There are two cars. They both point to the same prototype. Where's the miles? In the prototype, right? You say, give me the miles, please. I don't have it. Get it from the prototype. Increase the value of miles. Set it. Where are you going to set it? On the car, not on the prototype. Make sense? Very, very magical trick, isn't it? Very, very smart way of reusing objects. Let's see if that's true. So notice right here, I create car 1 here, and I create car 2 equals new car, let's say 2014, 2 different cars. Car 1 dot drive and car 1 dot miles. So by the way, before we do any of these, let's first ask for the miles values. So I'm going to say print out car 1 dot miles. Notice it's 0. Print out car 2 dot miles. Notice that's 0 too. Then I say car 1 dot drive, and then I ask for the car 1's miles. It's 10. Now I say car 2 dot miles. It is still 0. How so? Because sets are shallow, right? Where is the set happening? Well, the set is happening on line number 7. Read this as get the value of miles. So that is the same as this dot miles equals this dot miles plus distance, right? Where is this coming from? From the prototype, the first time. Where is it being set into? On the shallow, on the object, right? The next time you read it, where is it coming from? From the object, because now I have it, right? Next time you say, give me 1,000 please, I don't have to go to him, because I already have it. He's still unhappy that I kept his 1,000. But I can give it to you because I have it with me, right? So that is the benefit you see. Make sense? How this prototype works? You say, wait. If that is true, how do we know all of this is true? Let's give it a try right here. So I'm going to say var car 1 equals new car 2013, and I'm going to say for property in car 1, print out property. What does he say? He says it's got year, miles, and drive. A big liar, right? He says it's got all of that. What does he really have? Only the year. Where's the miles and drive coming from? From the prototype, right? How do we know? Well, let's look at this. So we could say plus car 1 dot has own property. Oh, has own property. Right? Now comes the truth. He says, well, here is mine, but I actually borrowed it from him. He's like smiling all now. The truth finally came out. That's my money. Yes, right? Miles and the drive came from that other one. Make sense so far? Well, let's look one more time. Now I say car 1 dot drive 10. Watch that carefully. So we drove the car. Now I say, tell me what your properties are, and this time, does it make sense? Notice how miles went from false to miles went to true, because sets are shallow. And this guy says, oh, now I have my own miles. Where's the drive coming from? That is still from the original. That's a function. I'm not changing the function. I'm just calling it. Make sense? So notice how, very brilliant, right? How the object deeply shares objects, but the minute you set it, gets its own copy. But if you go to car 2 right now and ask, where does the miles come from, what will it say? It's from the prototype, because we didn't change the car 2's miles. So that's how prototypes come into picture and how they are handled within JavaScript. So very powerful mechanism, as you can see here. So what did we do at this point? So we looked at the property, and we called a function called has own property. That's what we did, right? A has own property. We can get the properties using methods like this, but we can also do one more thing. We could say, for example, print line car1 dot year, but what if you have a variable called property equals year? Like in a web application. You don't know what the name is in code because it's coming as an input. Well, beauty of that is you could simply say over here, car1 a square bracket, and then the property name, and you can get the value like that. So you can use a very flexible syntax like this, where you can say car1 and get the property with a square bracket. So this gives a very nice dynamic behavior to get the values out. So you can also delete properties, but I recommend you don't do that. Because if you start deleting properties, it becomes very confusing to know what's available, what's not available. The only time I recommend you delete properties is if you really hate the people you work with, right? Otherwise, don't delete properties. It becomes really hard to work with it. Not only can you have class level methods, you can have instance level methods. Let's look at one thing here. Notice in this case, I can say car1.drive10. So you call the drive method. Now I'm going to say var Venkat's car equals new car, and I've got a beautiful car, 1984 model. And I'm going to say Venkat's car.drive, barely though, it'll drive. Let's say 1 mile, don't tax it too much. But my car has a feature I bet your car doesn't have. I can use my car to say break down. How does that work? I can simply say Venkat's car.breakdown equals, I could do something like that, plunk. But if I try your car.breakdown, sorry, you don't have that feature. So we can add functions to instances that don't exist on all the other instances. Look at the power, the dynamic nature, right? You can have methods on one object and not on other objects. You can even replace, from the testing point of view, look at how beautiful this is. You create an object, and only within your test, you can mock away one function. And just for the test, you can use a mock implementation rather than the original. Your test is over, the object is gone, and everything is back in shape. So this becomes extremely simple from the testability point of view as well in the code. So we looked at creating classes in this case, but what about inheritance? I'll skip that part, we're running out of time. But how do we deal with inheritance? Well, inheritance is very easy to build now. Let's say we have a vehicle class. And the vehicle over here, let's say contains a function. And here I'm going to say .drive. And let's simply say function, and I will simply say here, let's say distance, and we will say vehicle driving over here, plus distance. So now we say var car equals function, and this is the car that we're going to create. But I'm going to say car.prototype equals new vehicle. Make sense? So we create a car and attach the car's prototype to vehicle's object, not vehicle, but vehicle's object. So what is this going to do? Now I say var car1 equals new car, get a new car object, car1.drive10, and notice it's calling the vehicle's drive. That's what inheritance is, right? However, I'm going to go back to the car, and I say this.drive equals function, takes the distance, and what am I going to do here? Car driving, and notice how it went to car's drive method. But normally in Java or C#, you can call from a derived overridden method to the base method, isn't it? How do we do that here? What do you normally do in Java to do that? You call a super method, isn't it? Well, there's no super here. So think about that. How can you go from, let's do a couple of things. Let's go back to this code, and we will say this dot miles equal to 0. And then here we will say this dot miles plus equals to distance. There we go. So before we add the drive function, we have not added the drive function. Remove that. Now I say output car1.miles, and notice it's 10. So far so good, right? Now we go back over here, put the drive method. So this dot drive equals function, distance. And here I'm going to say car driving. Run the code. Miles is no longer 10. You got to fix that. But the question is, how do I call the base classes? First step, what should I go for? Prototype, that's correct. So let's find out how to get to the prototype. Output this dot proto. Make sense? Great. So tell me what this is about. This dot proto dot, what should I call? Drive, right? What should I pass to it? Distance. Run the code. What did it do? It called drive function. It says 10 on it, but there is still one problem. Did it change the 10 for the car properly? Did it set at this proper place? Let's try this one more time. Var car2 equals new car. So we create another car object, right? So we created two objects of car. Now we say here car2 dot miles, print the car's miles, car2 dot miles. Trouble, isn't it? What did I do wrong? I ended up modifying the miles in the prototype, which is wrong, plain wrong. So what should I do on line 12 to fix it? Any ideas? A call, or simply to apply this command. What should I say here? What should it be? I need to pass a collection. My collection is going to be what? Arguments. That's correct. Arguments. Notice how that fits in really nicely with the inheritance model, right? So we said, go call the prototypes drive method, run it in the context of the current object. So when you go to car2, its miles can get affected. You got to be very careful when you program with JavaScript. It's powered like a chainsaw, right? Vroom. Now you got active power on your hand. You can really cut things, but be careful, don't swing it around, right? You know what you're doing, you can reap the benefit of it. But you got to be very careful, you got to know what you're doing with it. A very powerful mechanism, as you can see. So this gives you an idea about how we can use inheritance model. Well, talk about array a little bit. They're weird in that they're not really arrays. They're kind of arrays wannabe. We already talked about exception handling and how we can throw different stuff. So finally, one concluding word. It's very important to maintain good code quality. If you want to maintain good code quality, there is a fantastic tool called JSLint, written by Douglas Crockford. And you can go to JSLint and you can type in a little JavaScript and it will tell you all the things you need to fix in it. Now, before you run JSLint, I highly recommend you sit down because it doesn't hold back anything. It will spit on you, it will slap you, it will call you by names. If you cannot handle that emotionally, don't use it. Ask somebody else to use it. It can be very draining. In fact, it made one guy so mad, he went on and created a tool called JSHint. JSHint will also slap you, but in the end it will hug you, just to make you feel better. The nice thing about JSHint is you can also use it in continuous integration to continuously check your code quality. So take a look at JSHint, H-I-N-T, or JSLint, either way. A fantastic book to read is the JavaScript, The Good Parts by Douglas Crockford. So take a look at that book as well. It has a wealth of details about how to write better JavaScript. If you're interested in downloading some of the code examples I have here, feel free to reach out to agiledeveloper.com, downloads link. And if I can answer any questions anytime, I would be delighted to get an email from you, and my email address is given up here on line number 3 as well. Hope you enjoyed that. Thank you.